Hello everyone, today I'm going to talk about what to look for on a mechanical unit in order to size the wire, the breaker, and the disconnect switch in Revit. So we have this train air handler unit. So this card sheet provides us the information, the electrical specs, in order for us to size the wire sizes, the breaker, and the disconnect switch. So, and this for this CAD sheet, it's telling us the voltage 460, three-phase, and 60 hertz, and it is full load amps of 16.28 amps and a MC8 of 19.78 amps, and a max fuse size or MOP, motor overcurrent protection of 30 amps. So what's the difference between the full load amps or the minimum circuit amps and the MOP? So the difference is that if FLA is a full load amps, uh, which is the sum of all FLA of all the electrical data. The MCA is the minimum circuit ampacity. It is chosen to guarantee that the wiring will not overheat under the expected operating conditions. The MCA should not be used to determine the normal operating current, but used for selecting wire sizes. You will have to use the 125% of the largest motor FLA plus the remaining sum. And for the MOP, is the maximum overcurrent protection, which is used for the circuit breakers to size the circuit breaker fuse size required to properly protect the equipment under anticipated fault condition. You will have to use the 25% of the largest motor FLA plus the remaining sum. So as you understand, it shows on the CAD sheet, shows the full load amps, the MC8, and the max fuse, the MOP of this equipment. So if you, let's say if you don't have the FLA, you have the kilowatts or the horsepower for this mechanical unit, there's some equations that you can find in order to determine um, in order to calculate for the MCA and then for the MOP. And here's some of the equations that in order to find the amperes, the amps, you can use the kilovolt amperes if you have the apparent power that provides you the apparent power, then you will have to calculate for the amperes, or if gives you the horsepower and not the FLA, then you will have to use this equation, the horsepower times 746 divided by the volts, the efficiency, the power factor times square root of 3, or if it gives you the kilowatts, the watts, and not the full load amps of that for that mechanical unit, you will have to use the kilowatts times 1000 divided by the volts times the power factors times the square root of 3. You can also use, depending on what type of motor, you can use the NEC code. The NEC code provides you with different tables, such as, let's say you have table 430.250, which is for induction motor type motors. It shows you a table with different horsepower and with the different voltages, 115, 200, 208, 230, 460, 575. So the NEC provides you with that type of information that can help you, that can also help you um, size for the wire size of the breaker or the disconnect switch. So So I have this disconnect switch here. It also shows the clearance. So I'm going to use this 800 unit. This is the air conditioner unit with the information that was provided in the cut sheet. So is I will power to the nearest panel, which is MP8740. I will call to the power, and it's a three-phase 480. And as you can see, it says other, so I will change that to air conditioner unit 0126B, where it shows in here. Then I'm going to annotate it. Annotate it so it can show the circuit number and where it's being and from what panel is it being fed from. And then I will also provide the size of the disconnect switch, the phase, and the NEMA rating. So go to comments. So this disconnect switch is not a non-fuse disconnect switch, so I'm going to change that. So the 30 is the size, the 3 is the phase, the 1 is the NEMA rating. As for indoors, there's different types of NEMA ratings for hazardous locations, for exterior, and for the interior NEMA ratings, depending on where is that panel or disconnect switch or anything electrical related that is enclosed. It can be rated for different categories. So this is NEMA 1, non-fuse, disconnect switch. So now we show this, but we also have to provide the parent power. The apparent power for this is, I think, that is correct. Let me check. So the voltage is 480 or 460 times the full load amps, 16.28. 460 times 16.28 times square root of 3, 12,971. That's the apparent power. So you will see the load in here distributed in each phase A, phase B, and phase C. So in all three phases. But now you will, as you can see, that it gave us the electrical cut sheet. It gives us the maximum fuse size that you can use. We will use the 30M for the motor overcurrent protection. And we will change that here in this panel schedule. And then we will have to determine the wire size. So in Revit gives you the usually provides you with the length. It's smart enough to provide you with the length. So it's about 118 feet, and it also gives you about 30 feet of extra length for the ups and downs on the wires. So for this, it gives you number 10, 3 number 10s, but you can also use you can do the voltage drop if you don't feel, if you want to double check on that, you can use calculate yourself. There's tables and the NEC code that can help you on that. And also we have a voltage drop calculator that can help us to size the wire sizes. So we have a 480, 3% voltage drop, three phase. We're gonna use copper uncoated, and here we're gonna use the MCA, the minimum circuit ampacity to size the wires. So it would be 19.78, and the length is about 117, but I'll give it to 120 just to round it up. So this is recommended, let's see, on 10 at 339 feet. 483 phase supercar, okay. So this is good, 19.78, 10 wire size. So we will go back to Revit. We will copy this 3 conductors and then change that to number 10, a 10 underground, and we're using the TC cable, tray cable for this. The grounding is different for each for TC cables. So this is basically what you look for whenever you're sizing a breaker, disconnect switch, and the wire sizes. You need to, from a mechanical unit, you need to look for the FLA, the full load amps, or the MCA. And if it shows you an MOP, if it doesn't, then you will have to size it, and you will have to use certain equations in order to get some information. Like if it doesn't provide you with the full load amps, but it provides you with the horsepower, then you have to calculate it, or you can go to the NEC book and find it and figure it out from there. Then you can from there you can size your disconnect switch, uh, wire sizes, and as well as the breaker size. And that is all. Thank you.